All right. So we did number 1. Oh, hold on. Hold on. All right. Number 2. Okay. X plus 7. What side is going to be congruent to x plus 7? Mariana? 15. So we just set these equal to each other. We get x plus 7 equals 15. How do we solve it? Isa?
Oh, wait, I was thinking I think I know.
Mariana?
You subtract 7 from both sides.
Uh-huh.
Me?
X equals 8. Cool beans?
I have a question.
Okay. Now, how do we know? Well, first off, guys, it told you that these two triangles are congruent, right? The diagram includes a pair of congruent triangles. If we were asked to prove that those two triangles are congruent, what theorem could prove congruence? Dylan?
Both side
Angle, side, angle. What do we need to add to our diagram? Just a little congruence mark here because it's a shared side.
Would you not add 8 plus 7? Which would equal the same thing?
Yeah, you could just do 8 plus 7 equals 15. Yep.
It doesn't matter if you didn't add it or not.
Doesn't matter. Yep. Christian? What about? Right now? Oh, thank you. Okay. Yes.
It's not on this, but how many lessons are we doing, like, quizzing on Friday?
Just 2. It says it on the board.
Oh, sorry.
It's okay. Okay. Number trace. Número 3. Emma?
Since it's the angle side theorem, you set 2x plus 1 equal to 5.
Angle side is a thing.
Oh, I guess angle side angle too. No, it could be angle side or angle side angle.
Okay, yep, either one. Because if we know that those two angles are congruent, then these two angles also need to be congruent.
Oh, okay, yeah.
Okay, because by the third angles theorem. Okay, but all we need to do is set 2x plus 1 equal to 5. And what'd you get, Emma?
2.
2x equals 4, and then x equals 2. Okay? All right, and last but not least, number 4.
Yeah, I didn't get this one.
Yeah,
This one's fun. Gabby, what'd you get?
Okay, so you put 2x plus 9 equal to 3 minus 4x.
Uh-huh.
And then you subtract, so I subtracted 3 from both sides.
Okay.
And then it's 2x plus 6 equals negative 4x. And then you subtract 6 from both sides. So now it's 2x equals negative 4x minus 6. And then you add 4x to both sides. And then you're left with 6x equals negative 6. You divide it by itself.
Yep.
And then you get x equals negative 1.
Perfect.
Right?
Yeah, that's right.
Wait, I did that wrong.
See, I'm just not good at algebra.
I'm disgusting at algebra. This is going to be terrible next year. Wait, and then what is the
Be positive.
Ah, yes, this one should have been angle side because the side in the middle is shared. We've got an angle here, an angle here, an angle here, and an angle here, and then a side and a side. But remember, these questions did not ask you to prove that the two triangles are congruent, right? It told you that the triangles are congruent, and it asked you to just find the value of x from the diagram. Section 1, okay? So we are skipping 5.8, okay? You guys do not need to know it. All those questions that were on that review, you don't need to learn them, okay? We're done with chapter 5, okay? We're jumping into chapter 6. And the first lesson is about perpendicular and angle bisectors. Who remembers what a bisector is? Savannah?
Something that cuts a line in half.
Excellent. It cuts it
In the middle.
in half, down the middle, however you want to remember it, okay? From cutting it in half, okay, we are always going to get 2 equal parts, regardless of whether it's an angle or a side. Cool beans on that so far?
Yes.
All right. I think a perpendicular bisector is? Xavier? Very good. It's a bisector that creates a perpendicular symbol. Or a bisector that creates a perpendicular, okay? So formally, it's called a segment, ray, line, or plane that is perpendicular to a segment at its midpoint, okay? Now, if it goes through the midpoint, that creates a bisector, and it also needs to be perpendicular, so it creates a 90-degree angle. So guys, perpendicular bisectors need two parts, okay? They need the right angle, and they need the congruence symbols on each side to say that both of those sides, or both of those segments, are equal to each other. So AP is equal to what? BP. Right? And then CP is perpendicular. CP is a ray to what? AB. Okay?
Would you have to put the lines on top of AP and BP?
On top of a what?
Like the lines like this.
Yes, you do. Oh, no. That's if you were saying that they were congruent. That's a good question, Gabby. Okay? So this would mean the congruence statement. If you're just going to say the AP and BP, that's saying the distance between A and P is equal to the distance between B and P. Okay? And equidistance just means the same distance. I believe we've covered that in the past. Okay? If you forgot it, it's down there for you. All right, so perpendicular bisector means that it cuts it in half and it also forms a 90-degree angle. We Gucci? All right, the perpendicular bisector theorem. Okay, now before you write anything down, just listen to my amazing voice. It says, in a plane, if a point lies on the perpendicular bisector of a segment, then the point is the same distance, it's equidistant from the points of the segment.
What?
Okay, confusing, right? What is the perpendicular bisector? Still don't write anything down, guys. What is the perpendicular bisector of AB? Gabby. CP. So highlight that. CP. All the theorem is saying is if there's a point that lies on CP, it's the same distance from A as it is to B. So in other words, what's a point that lies on CP? Point C. Do you guys see that?
Yeah.
It's the same distance from A to B. So this segment, AC, is congruent to what segment? CB. Easy, right? But you have to know that CP is what? Perpendicular bisector, okay? And a perpendicular bisector requires how many parts? 2. Needs to have the right angle and what else? The congruence marks, okay? It needs to be a bisector, so it needs to go through the midpoint, which is P, and it needs to be a 90-degree angle, okay? That is what we call the perpendicular bisector theorem.
Why is there so many slides in this one?
Because
All right. What would the converse of that theorem say? And would it be true? Because remember, converse, right, requires an if-then statement. Do you agree?
so it would be.
Hold on. Write it down.
Oh, okay.
Write it down, and then let's talk about it.
If that statement,
We're writing now. We're doing.
Write it as a what?
It would be.
All right. What would the converse of the perpendicular bisector theorem say? And is it true? So go back, read it out for me. So it says if
Equal distance from the endpoint of the segment, then the point line on the perpendicular bisector.
it was if what?
If the point is equal distance from the endpoint.
If the point is equidistant
From the endpoint of the segment. Right.
from the endpoints
Of the segment.
of the segment,
Then the point lies.
then the point
On the perpendicular bisector
is on the perpendicular bisector
of the segments.
So
of the segment. Okay? Let's draw a little picture. No. We're going to draw a picture on this diagram, okay? So draw a little segment down here. Nice and pretty. A, B. And it says if the point is equidistant from the endpoints of the segment. So draw a point up here, label it C. If these two are the same, then the point is on the perpendicular bisector of the segment. So we're reversing the order, okay? It's saying if we know that the two segments, right, that lead to the endpoints, in other words, pick a point C, right? And if this distance is the same as this distance, does it lie on the perpendicular bisector? And the answer is to our image, okay? We would say that C does indeed lie on the perpendicular bisector because of these two congruence marks, okay? What the heck is yes, okay? The converse of the perpendicular bisector theorem says, in a plane, if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So in other words, if DA is equal to DB, then the point D lies on the perpendicular bisector of AB. So if we go...
Wait, are we actually getting back into if and?
Like converse and stuff? No.
Oh.
Okay? We just did that as like a little practice example. Okay? But do you guys remember when I think we did like a quiz or something in the past where I was like, oh, with the angles. And I was like, be very careful about the converse, when to use the converse, when to use the regular theorem, okay? You need to know the difference for this one, okay? Big difference. So star this one, okay? Super important that you know the difference between the converse and the regular theorem. Because if you put on your paper that you're using the regular theorem and you should have been using the converse, you're going to get it wrong, okay? All right. Questions?
Can you go up to like the drawing before?
Siete. What's happened? Why do you think a point cannot be a perpendicular bisector? It's just a bisector, okay? Write that down. It's just a bisector. How does it need to be perpendicular bisector? Can you have a perpendicular angle mark at a point? No, you need some sort of line, ray, or segment or something. Can a line segment be a perpendicular bisector? Can a plane, think about this, can a plane be a perpendicular bisector? Sure can, okay? Do you remember when we had lines that looked like this? And our plane was like this? And then it was like do, and then it drew a little perpendicular line to the plane? Ah, perpendicular bisector. Whoops, hold on. Those need to be endpoints. And then this needs to be the same distance as this. Wow, that was actually really good, guys. Appreciate it.
The only thing to fear...
BD is the perpendicular bisector of AC. Find AD, okay? Now, before we do anything, I know a lot of you guys are like, oh, just set them equal to each other. Super easy, okay? Yes, it is that easy, but let's use the information that we're given first. If BD is the perpendicular bisector of AC, what information does that give us about our diagram? Dylan Brass.
Using my phone name was kind of weird.
Go for it.
Like, it makes both sides equal.
What are the both sides?
AB and BC.
Excellent. So put congruence marks there. What else does it tell us if it's the perpendicular bisector? Savannah.
It makes angle BBA and DBC 90 degrees.
Excellent. These two angles are 90 degrees. If we know it's the perpendicular bisector, what do we know about DC and DA? Emma?
That they are congruent.
Excellent. So put your congruence marks. Oh, did we notice something? The 3x plus 14 needs to equal 5x. So let's write that down. 3x plus 14 needs to equal 5x by what theorem?
Perpendicular bisector theorem.
By the perpendicular bisector theorem.
Do we have to say that?
Of course you do.
Wait,
Okay?
do the drawing and everything? There's like a question on the test. You have to like write everything
Yep.
out.
Okay?
No.
Solving this, what do I do? This is our algebra steps, okay?
Minus 14. Oh no. Minus 3x.
Zoe, what would you do?
Oh my god, they're wrong.
Subtract 3x. There we go. We're going to get 14 equals 2x. And then, Jaden, what do I do?
You divide by 2.
And I get x equals 7.
See it there.
Oh, there we go.
Now I put 5x.
Questions on example bisector of WY. Underline that statement and let's put some marks on our diagram. What does that tell us in the diagram?
That ZX is the bisector.
Very good. So if it's the bisector, what two segments are congruent? Emma?
WX and XY.
Good. Put those on there. Now, it gave you a piece. It gave you that ZX is perpendicular to WY. Just put that 90 degrees on the other side. Okay? Now, what else if it's on the perpendicular bisector? So we know Z lies on the perpendicular bisector. There's one more piece of information we can gather from the perpendicular bisector theorem. Mariana? Very good. Why? Yep, it's on the perpendicular bisector. So the distance between that point and the endpoints of your segment need to be the same. It also says that YZ is 13.75. Do you guys see that?
Wait, hold on. I'm still trying to do the
Oh wait, we're still doing that.
So what would WZ be? 13.75. So our answer is just 13.75. And how did we know that?
They're equal.
Perpendicular bisector. Yep. I don't know, maybe. Is the perpendicular bisector of WY. Let's go ahead, use that information, so underline it in a different color. And let's use that information. What do I need to put congruence marks on?
The W and the Y.
WX and XY are going to be congruent. Also, add that 90-degree mark to the other side. And WZ is 4n minus 13. And YZ is n plus 17. What do you guys think I do? Okay, so we're going to write 4n minus 13 equals n plus 17. Now, why did I set those two equal to each other? Savannah? Excellent. Perpendicular bisector theorem. Okay? Whenever they tell you that something's a perpendicular bisector, okay, that would be the perpendicular bisector theorem. So now, all we do is solve this. So we're going to subtract 17 from both sides. We're going to get 4n minus 30 equals n. We're going to subtract 4n from both sides. We're going to get negative 30 equals n minus 4n is negative 3n. And then we divide by negative 3, divide by negative 3, n equals 10. You guys with me? Am I done?
No.
Why not?
You have to plug it in.
Very good. It says find YZ. Do you guys see that? What was the value of YZ? So YZ equals n plus 17. What's n?
10.
So plug in 10. What's 10 plus 17, guys?
27.
YZ, oops,
I think.
YZ equals 27. Not so bad, right? Theorem, okay? So we're going to put by the converse of perpendicular bisector theorem. So by converse perpendicular bisector theorem, what needs to be equal to each other? Yx needs to be equal to Wx, right? Because we already know it's perpendicular, but it's also a bisector. And if those two are equal, just like what Isa said, the 14.8 just gets divided by 2, so Wx equals 7.4. It's just 14.8 divided by 2. What? You're good? Then that would be, our question would be over. What other information could we be given to prove that? Emma?
There's 2, right?
Yeah?
So either that KL is equal to LM,
We already know that.
or that KN is congruent to NN.
There it is. If Kn is congruent to Nm, then Ln is perpendicular to Kn. Now, what theorem proves that? What theorem proves that?
This will be the converse.
Converse perpendicular bisector theorem.
If they gave you that was a right angle, would it be perpendicular bisector theorem?
If it gave you that it was a right angle,
Yeah.
well, then it wouldn't be asking you to prove that it's a right angle.
Wait, so when it asks you to prove it, it's converse.
What?
When it asks you to prove it, it's converse.
When it asks you to prove that it is a perpendicular bisector theorem, then it's the converse. You guys, did we know that it was a bisector?
Yeah.
Yes. Did we know that it was perpendicular?
Yeah.
No.
Oh.
Do you see that?
No. Yeah.
We didn't know that it was a 90-degree angle here, right? That's what we're proving. That's why it's the converse. If we're given that it's a perpendicular bisector, then it's the regular theorem. Let's do another example, see if it clicks.
You only put converse perpendicular bisector when you're trying to figure out if it's perpendicular.
Correct.
But when it's perpendicular and you say regular.
Yep.
Okay.
Okay? All right. If a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. Okay? This is a different theorem, but it still involves a bisector. Okay? This theorem says, okay, if AD bisects BAC, that means it cuts it into two equal parts. Do you guys agree? Okay, so AD is this ray, right? If that bisected our original angle, which was BAC, then we know that the two angles that are formed from that need to be congruent, okay? Any point on AD is the same distance from those two sides of the angle, okay? Now, D, how we get the distance between a point on a line and a point on another line is form a 90-degree angle with that line, okay? So this angle needs to be 90 between DC and AC. And the angle over here between AB and BD also needs to be 90. It needs to be perpendicular, okay? Because the distance between a point, in which case, in our case is D, the distance between a point and a line needs to be 90 degrees to find the distance from that line. Okay, so we can prove that those two triangles are congruent by angle, angle, side, which forms the angle bisector theorem. The converse of the angle bisector theorem, if a point is on the interior of an angle and it's the same distance from the sides of the angle, then it must lie on the bisector of the angle, okay? So, we don't know that AD is the bisector, okay? But if point D is the same distance between both the sides of the angle, then we know that AD then has to be the bisector, okay? It's the same theorem, just in reverse, okay? So if we know that point D is the same distance from AB and AC, then D lies on the angle bisector. A lot of you already know. Okay, just set x equals. Mariana? Very good. This now becomes the bisector because those two are congruent. Therefore, the distance from this point to this side is going to be the same as this distance from this point to this side. So this 15 needs to be congruent to the x, so x equals 15. By what theorem?
Is it the converse of the perpendicular bisector theorem? No?
Okay, this would be the regular angle bisector theorem. Were we given that it's the bisector?
Oh.
Yes, because of these 27 degree marks. Do you guys see that?
No, I do not. Oh, I do because it's in the middle of.
But if
Okay, now if it didn't tell us that it was the bisector, right? And it told us that these were both 15, and it asked us what x is over here, then it would be the converse, okay? All right, let's do another example. Find the value of x, okay? Right off the bat, are we looking for the angle or for the side?
Angle.
Okay, those have little degree marks, right? So guess what we're going to be using?
Converse.
This is going to be an example of the converse. Angle bisector. Okay? Do you see how our given information is different? It's telling us that this distance between this point and these two sides are the same. Do you guys see that? So now it's like, okay, what are the measures of the angles? What do you think we do with 3x plus 5 and 4x minus 6?
Oh.
Yep.
You put them equal to each other.
Why do they need to be equal?
Because they're part of the bisector, and since it splits it in two, they both have to equal the same thing.
Very good. Because we know that those distances are the same, this point has to lie on the angle bisector. So therefore, this angle needs to be congruent to this one. So 3x plus 5 equals 4x minus 6. You would just add 6 to both sides. You would get 3x plus 11 equals 4x. Subtract 3x, and you would get 11 equals x. Was it asking me for the value of x or the angle?
Yes.
The value of x. So are we done? Yes, we're done. We don't need to plug it back in.
Oh, okay.
It says it just said find the value of x. Okay? Now if it said find the value of, and it had letters here like A, B, and C, then you would plug it back in. Yep.
If you were to plug it back in on the test, would you get extra points or no?
No, definitely not extra points. Okay? Try this one. right off the bat, guys, do we use the converse or the regular angle bisector theorem? Xavier,
Sorry.
what do you think, Xavier?
Yes.
No.
No.
What?
What are we given here?
Oh.
Are we given that it's a bisector?
Looking at the. Yes.
Do you see how we're given that these are the same? What don't we know? That these are the same, right? So this is the regular angle bisector theorem. Correct. Okay? If they give you the sides, then you're like, okay, it's the converse. If they give you the angles, which they just told us these are congruent, right? It's the angle bisector theorem. So what needs to be true about those two blue lines? They're equal. So what's my equation?
6x plus 5.
Perfect. You can subtract 5x from both sides. You would get x minus 5 equals 0. And then what can I do to solve for x? You just add 5 to both sides. You would get x equals 5. You should have got, yeah, you could do it a different way. You should have gotten x equals 5 though at the end. It says write an equation of the perpendicular bisector of the segment with the points P, -2, 3, and Q, 4, 1. Okay? These questions have two parts. Because in order to be a perpendicular bisector, you need to pass through the midpoint. And you also need to have the reciprocal slope. Okay? All right, so the midpoint, if you remember, is just a formula, okay? It's x1 plus x2 over 2, comma, y1 plus y2 over 2. So, this is x1, this is y1, this is x2, this is y2.
You seem oddly cheerful for this.
Okay? You add your x values together and divide by 2. You're basically finding the average between those 2 points. Okay? x1 plus x2 is going to be -2 plus 4 over 2, comma, 3 plus 1 over 2.
Wait. 2.
All I'm doing is adding my x values, dividing by 2, adding my y values, dividing by 2. We're going to get that my midpoint is at +2 over 2 and 4 over 2. These simplify, so my midpoint is at 1, 2. Once we find the slope, we can find the opposite reciprocal of that slope, and then we know the slope and the point, okay? So, y2 is 1 minus 3 over x2 is 4 minus -2. This is going to give me -2 over 6, which simplifies to -1 over 3. Now remember, if our line needs to be perpendicular to this, we need to find the opposite reciprocal, which is just 3. So the slope of our line needs to be 3, and it needs to go through the point 1, 2. No, it's not. Guess how many questions are going to be on your... Okay, so we have our slope and we have our point, which is 1, 2. So there's actually 2 ways you can finish off this problem, okay? You can either use the slope of m equals 3 and the point 1, 2, and use what's called the point slope form, which is y minus y1 equals m times x minus x1, okay? x1 being the x coordinate of your point and y1 being the y coordinate of your point. You'll get y minus 2 equals m, which is 3, minus x1, which is x minus 1, okay? Then you're going to distribute the 3, because you need to change this into slope-intercept form. You're going to get y minus 2 equals 3x minus 3. We distributed the 3 to both terms, and then you're just going to add 2 to both sides. And you're going to get y equals 3x minus 1. And that is your final answer, okay? This is the first method you could use, and that matches what we got, okay? That's the perpendicular bisector. That's the equation of our perpendicular bisector, okay? The second way you could do it, using the slope is 3, and your x comma y is 1 comma 2, is use the formula y equals mx plus b. This is regular slope-intercept form. And just plug in for m for x and for y, and then solve for b. So you're going to get y, which is 2, equals m, which is 3, times x, which is 1, plus b. So we're going to get 2 equals 3 times 1 is just 3, plus b, and then you just subtract 3 from both sides. Once you subtract 3, you're going to get negative 1 equals b. Now, we found what b is, so now we just plug both b and m into our formula. We're going to get y equals 3x minus 1. And either way that you do it, you're going to get the same answer, okay, which we did. And that's the equation of your perpendicular bisector, okay? So remember, there's 2 steps. Find the midpoint, find the reciprocal of the slope, opposite reciprocal, excuse me, okay? This should say opposite reciprocal. Once you found both of those, then you just use the slope and the point and you plug it into your equation, either point-slope form or slope-intercept form. And then you can solve.